The name of the center is the Center for Autonomous Construction and Manufacturing at Scale. There's multiple things we're looking at doing. So one is coming up with new and state-of-the-art technologies for the construction side of the house, dealing with the soldier in the battlefield primarily, and making sure they're protected.
You're starting with more construction-facing projects as it relates to the Army Corps. However, we're trying to take a lot of those technologies and repurpose them for other applications.
We work on multiple platforms in my group, everything from underwater systems to aerial to ground vehicles.
We're doing underwater pipeline inspection. Pipelines are like deep underwater, so it's very difficult to do the maintenance or the repair of them. People use like a human diver, like dive down and see, okay, there's a leak in the pipeline, or there's like some damage on it, but it's very inefficient and it's very dangerous for a human diver. So then people start to use like some like sensors along the line. From this sensor to the next sensor might be like a kilometers away, so the range to search is really huge. So now what we're doing is to use an autonomous underwater vehicle that navigates itself to run along the pipeline and detect the leaks. So that's why our leak detection can be very high accuracy, high efficiency, and it saves a lot of human labor.
I've been working with the Jackal. It's a skid steer vehicle, which means the left half and the right half, those two sides kind of drive together, similar to like a tank, if you will. And so I've worked specifically just with the driving component of it. And we use a process called dead reckoning. It's a sailing term. Basically, where is the robot given where it started? And so using that information and kind of a preset set of waypoints for a given path, we can tell the robot how to drive. So are you to the left of the path? Are you to the right of the path? What is your orientation relative to it? And the idea is that we try to bring it to a zero state to where it's driving right on top of the line. Because we work with the Army Corps, a lot of the construction and driving technology we've developed can be employed on the battlefield. It's going to make sure that, you know, for people that are in those battlefields, they can still safely transfer equipment or other kind of needed resources safely.
The aerial systems we've used primarily for understanding terrain before we move systems in there, looking at tree cover and ground type and moisture content and soil and the contours of the ground.
The things we have our robots do are menial. They're running equipment, they're detecting obstacles. These are things that would take a lot of time for a person to do. And so by having a robot do it for those people, it frees them to spend their resources on more delicate tasks.
Robotics, in this case for off-road equipment and other things, are not replacing people. They're about dealing with the dull, dirty, and dangerous applications.
Autonomous vehicle is the future. What we're doing is very important to not only the nation, but the world.
You know, being able to do real world things with things that are in the lab, taking it to the real world and solving real problems. And I think that's the takeaway.